Alright, so today we have 3.4 notes, parallel and perpendicular lines. Today's learning target, I can write the equation of lines parallel and perpendicular to other lines that go through certain points. Alright, as a review to yesterday, parallel lines have the same slope. Also, because they have the same slope, they will never touch. Also, as a review to yesterday, perpendicular lines, they intersect at 90-degree angles. Okay. Here we go. Number one, write the equation of a line that is parallel to y equals negative 2x plus 5 that goes through negative 1, positive 4. Okay, so our original slope was negative 2. We are dealing with parallel. Parallel is going to mean same to us. So our new slope will also be negative 2. So we're going to use the point slope formula. Y minus y1 equals m parentheses x minus x1, close parentheses. Remember, whenever we put in our x1 and our y1, whenever it goes in, it's going to be the opposite. So a negative or a minus 1, when put in, becomes a plus. A positive 4 becomes a minus 4. So y minus 4 equals a slope of negative 2, parentheses x, and originally it was a minus 1, so now it's going to be a plus 1. Right. Step 1, of course, is to distribute. Negative 2 times x is negative 2x. Negative 2 times 1 is, of course, negative 2. Rewrite the left side. And our last step is, of course, to get y by itself, which is simply going to be add over the 4, add over the 4, resulting in y equals negative 2x plus 2. And that is your new equation. Now, in case you want to check and make sure that that is in fact correct, you always have the ability to graph it in your calculator, and you can observe these things. So new document, no, I don't want to save, add a graph, add a graph. I graphed the original one, which was negative 2x plus 5, enter. I hit tab. I graphed the second equation, which is negative 2x plus 2, enter. I can recognize that they are parallel, so that means we are good. Okay, so the next one is a tad bit different. Instead of giving us an equation to work with, they give us a set of data to the right here. So write the equation of a line that is parallel to the line represented by the given table that goes through the point 512. Alright, so the first thing we have to do is establish the slope of our table. Remember, slope is always y over x. So my x's, I can see that from 4 to 12 to 16, they are increasing by 4. So x goes on the bottom, so 4 on the bottom. I can see that my y's are increasing by 1, so 1 goes on top. So my original slope was 1/4. Since this is parallel, parallel is going to again mean the same to us, so our new slope will also be 1/4. And now I'm going to show you a little bit of a different way to solve this one opposed to the point slope form. Y equals mx plus b. All of us, for the most part, have that memorized. There are 4 variables or unknowns in y equals mx plus b. Y, m, x, and b. Right now we have m, which is our slope, we have an x, and we have a y. So the only thing we're really having to find right now is our b. So since there's only one unknown, I can plug in for all the other ones, solve for that b. So my y value is 12, my m value is 1/4, my x value is 5, and I need to solve for this b out here. Right. 1/4 times 5. Remember what I've told my classes? Fractions are just simple as multiplying and dividing at the same time. So we're going to multiply by the top number and then divide by the bottom number. All right? So 12 equals 1 times 5 is 5. 5 divided by 4 is 5 over 4. It does not reduce, plus b. All right? And our last step to get b by itself is to subtract over the 5/4. Subtract over the 5/4. I know that's uncomfortable for some of us, and that's going to tell us that b equals, we'll find out here, add a calculator screen, 12 minus 5 divided by 4, enter. That gives us 43 over 4. Let's go ahead and just see what that looks like in a decimal. It's a prettier decimal, so that's what I'm going to write, 10.75. So now that I have my b value and I have my m value from before, I can go ahead and put those two things together, and that's going to become my equation. And that's your answer. Let y'all take a look at that for a moment. And then we'll move down to number 3. So the 1 and 2 were parallel lines. 3 and 4 will be perpendicular lines. All right, write the equation of a line that is perpendicular to y equals negative 3x plus 5 that goes through the point 1, negative 4. Okay, so our original slope was negative 3. I like to think of it as negative 3 over 1. Now whenever we see perpendicular, that's going to mean opposite slope. So we needed to change the sign and flip the fraction. So this was a negative fraction. Now the new one will be positive. This was 3 over 1. When I flip it, it will be 1 over 3. So our new slope is 1/3. Right? We're going to use point slope again for this one. And once more, I'll write it out for us. Y minus y1 equals m parentheses x minus x1, close parentheses. Okay, I'm going to label this x1, y1, and this is my new m right here. Right. As I plug them in, make sure I do the opposite. So a minus 4 goes in as a plus 4. My m just simply goes in as 1/3. And my positive 1 goes in as a minus 1. Step 1 for point slope would be to distribute. 1/3 times x is 1/3 x. 1/3 times negative 1 would be a negative 1/3. And my last step, of course, is to move over whatever's next to y, which would be a minus 4, and let's see here. Let's see what our answer ends up looking like. That's going to be an ugly answer anyway, so we'll keep it like this. Negative 1/3 minus 4 enter is going to be negative 13 over 3. So that gives us y equals 1/3 x minus 13 over 3. And that is your equation. All right, just for fun, just like we did before, let's go ahead and graph it and confirm that they are perpendicular. So menu, new document, no, I don't want to save, add a graph. Type in negative 3x plus 5, enter. Tab 1 divided by 3x minus 13 divided by 3, enter. I see they intersect. To me, that looks like 90-degree angles, so we did a good job. Okay. So perpendicular, write the equation of a line that is perpendicular to this equation, 4 divided by 3x plus 8, that goes through the point negative 1, 4. So x and y. Again, this time I'm going to use y equals mx plus b, the same strategy we used for number 2. My original slope was 4/3. Since it's perpendicular, I have to do the opposite, which means everything has to be the opposite. So this one is positive, which means the new one is negative. This one is 4 over 3. If I flip it, it is now 3 over 4. And that is my new m value. Okay, we're going to plug in our parts here. So our y is 4. Our m is negative 3 over 4. our x is negative 1, and our b is what we're going to solve for. So let's go ahead and get our negatives out of the way. A negative and a negative will turn this into a positive. Okay, and then 1 times 3 over 4 is just 3 over 4 plus b. Okay. Your last step to get b by itself is to subtract over the 3/4. Subtract over the 3/4. I know we don't like fractions, so I'm going to pull out my calculator and let it do all the work for me. A calculator. I'm going to do 4 minus 3, put it in parentheses just in case, close parentheses, control enter, and it tells me that b equals 3.25, which I like, it looks pretty, and so the equation is y equals 4 over 3x plus 3.25. And if you were just to simply leave that as a fraction, which is perfectly fine, which is honestly probably how you'll see it on your test, that would look like this, 13 over 4. Right, and there's your equation. Write the equation in a line that is perpendicular. So first off, perpendicular, we're thinking opposite. That goes through the point 6, negative 4. So original slope was 6. The new slope, or we could also think of it as 6 over 1. The new slope needs to be negative because the first slope was positive, and then you need to flip that to give you 1/6. Right. We can use point slope again. Y minus y1 equals m parentheses x minus x1, close parentheses. Here's my x1, here's my y1. Remember, whenever we put it in, it needs to go opposite. So y1 was a negative, so within it, it's going to be a plus 4. The slope is negative 1/6, and our x would be x. Positive 6 would go in as in minus 6. Alright, I'm going to distribute everything here. So negative 1/6 times x is negative 1/6 x. Negative and a negative make a positive. 1 times 6 is 6. 6 divided by 6 is 1. And our last step is to subtract over the 4. Subtract over the 4. That gives me y equals negative 1/6 x minus 3. And again, you can graph those to check and see if it is correct. Number 6, perpendicular once more, meaning opposite. So we need to determine our original slope. So we have our x's, remember slope is y over x. Our original slope is plus 2, so that means our x is 2. Our y's are increasing by 5, so that would be 5 over 2. Perpendicular, of course, meaning opposite. So this one's positive, so the new one is negative. If I flip 5 over 2, that's going to give me 2 over 5, so negative 2/5. Again, we have our points here. We have our x, we have our y. So if I plug those into y equals mx plus b. Now I'm doing it 2 different ways. You figure out which way you like the most and stick to that one way. You don't have to keep switching back and forth like me. Alright, so your y is 9 equals negative 2/5 x, which is negative 3 plus b. We're solving for b here. Alright, a negative and a negative make a positive. 2 times 3 is 6. Divided by 5 does not reduce. And then we still have our b over here. The last step is to subtract 9/5. Subtract 6/5. Subtract 6/5. 9 minus 6/5. Enter. B equals 39 over 5, which tells us our equation is y equals our slope of negative 2/5 x plus 39 over 5. It's not pretty, but it is correct. All right, moving down to our graphs. I write the equation of the line is perpendicular to the line graphed. That goes through the point 5, 15. Okay. All right, so let's see here. Our original slope. So first thing we notice that it's positive. And then we need to find perfect points. There's one perfect point. I hate these. There it is. There's another perfect point. So let's see. I'm going to go over 1, 2, 3, 4, 5. I'm going to go up 3. So my original slope was 3 over 5. Which means my new slope is going to be the opposite. So I'm going to flip it, and that's going to give me 5/3. My original one was positive, so my new one will be negative. All right. Since we have a graph, we're able to do a few different things here. It doesn't go all the way to where I want it to go, but it's all right. So I'm going to go over 5, up 12. So 1, 2. So that's 1 point. Now, whenever I start doing this, I can tell that my graph is going to intersect somewhere out here, which means since I can't see that graph, I'm going to have to do the math that goes with it. So, here we go. X1, Y1. Y minus 12 equals a slope of negative 5/3, parentheses x minus 5. Okay. Step 1, to distribute, negative 5/3 times x is negative 5/3 x. A negative and a negative make a positive. 5 times 5 is 25. 25 divided by 3 stays as a fraction. And then your last step is to add over the 12. Add over the 12. And let's just see what the calculator tells us. 25 divided by 3 plus 12. 61 over 3. So y equals negative 5/3 x plus 61 over 3. And finally, the last one here. Okay, so our original slope, we want to know a line that's parallel to this line and goes to the point 4, 2. Parallel, of course, means same. All right, so our slope here is, there's a point. There's another perfect point. So we go over 1, 2, 3, 4, up 2. So our original slope was 2 over 4, which we all know reduces to 1/2. All right, since it's parallel, our new slope is also 1/2. Now this time, like I was trying to do before, it should be on the graph. So, our point is over 4, up 2. If I continue my pattern, going down 1 over 2, down 1 over 2, down 1 over 2, I can construct the line. Let's see here, straight edge, there's one. So if I connect those lines, so my new equation will be y equals 1/2 x, and I can tell that it crosses at 0, 0. So I could put plus 0, but I don't necessarily have to, and it's more correct to just say y equals 1/2 x. And that is it.